All right, guess who gets to do some more practicing? In fact, after you complete this really short exercise, you're going to have a real good idea of whether or not you understand this material well enough to keep moving into more complicated territory. So make sure you take advantage of the opportunity to check yourself here and test these arguments for validity. All right, so I'm giving you two arguments here. First argument says this: all students are rascals, therefore all rascals are students. Second argument says no students are rascals, therefore no rascals are students. And you're going to determine whether or not these two immediate inferences are valid or invalid by creating a Venn diagram for each. And remember, you're going to diagram the premise statement only, never the conclusion. And if after marking that premise statement, you see in that one and the same Venn diagram your conclusion statement also represented, then you know that that immediate inference is valid. But if after marking the premise statement, you do not see the conclusion represented by that Venn diagram, then the argument is invalid. All right, so why don't you go ahead and pause your video, and when you're ready to check your work, go ahead and restart. All right, so argument number one: all students are rascals, therefore all rascals are students. So students is our subject term of the premise, rascals is our predicate term, so we mark our circles accordingly. Now, how do we mark all students are rascals? If you marked your Venn diagram like this, you actually marked the conclusion statement, because what this shows is that all the rascals that exist are also students. But our premise doesn't say that. Our premise says all students are rascals. If you shaded out area 2, then you illustrated the statement no students are rascals, and that's not our premise statement. But if you shaded out area 1, you shaded the premise correctly, okay? Because now that shows that all the students that exist are right here in area 2. And area 2 is also an area where the rascals are. So this shows that all students are rascals. Now here's the question: does the conclusion statement also appear in this Venn diagram? And the answer is no, because there are rascals in either area 2 or area 3 or both, right? There could be rascals right over here in area 3. Maybe there isn't, but maybe there is, okay? So the conclusion statement, all rascals are students, doesn't show up after diagramming the premise, and that tells us this is an invalid argument. The conclusion statement does not immediately follow from the premise. We would have to have more information, more premises to figure out if the conclusion of this argument is true or false. Just knowing this premise statement is true and illustrating it as such doesn't tell us anything about the conclusion, and so the argument is invalid. Now take a look at this argument. No students are rascals, therefore no rascals are students. If you marked your Venn diagram like that, you did it correctly. And you can see that after shading in area 2 to show that no students are rascals, the conclusion statement of this argument also appears. No rascals are students, because there's nobody in area 2. We turned out the lights. After learning the premise statement, no students are rascals was true. So we turned out the lights in this area, and that proves that this argument is valid. There's no way for that conclusion to be false when the premise is true, and that tells us we have a good, reliable, valid argument.